Okay, so in this class, we will talk about a special branch of physics which is known as thermodynamics, and the first topic is temperature. Okay, so it's a very easy topic, and some of the formulas you need to remember. So there are three scales of temperature. The first one is Celsius, another one is Fahrenheit, and the third one is Kelvin. Okay, so there are three scales: Celsius, Fahrenheit, and Kelvin. So we need to remember the formula of Celsius. So F minus 32 over 9 equals to C by 5. So where F is Fahrenheit and C is Celsius, right? So if we simplify it, we get 9C equals to 5 F minus 32. So you need to remember this formula, right, to solve the numericals. Okay. Next is if if Celsius is given to you and you need to change it into Kelvin, or Kelvin is given to you, you need to change in Celsius. So you need to use this formula. So always remember this formula, right? This one. So Kelvin equals to Celsius plus 273, right? So this formula you need to remember, and this formula you need to remember. So if anything is given, Celsius plus 273 equals to Kelvin, right? Now, Kelvin or absolute scale temperature. So this we don't use in the in our right in our calculations or in our numericals. So if you know these two formulas, that's a more than enough. Now, thermal expansion of solids and liquids. So, when temperature increases, its volume increases, right? We all know that. This is known as thermal expansion, right? So, whenever there is a increase in a temperature, there is an increase in the volume as well. Like in a buildings, in railway tracks, if there is too much heat, they expand to some point and then their volume is increased, right? So there are some formulas you need to remember. The first one is alpha, and another one is beta, right? So these two formulas you need to remember. So alpha is known as average coefficient of linear expansion. Average coefficient of linear expansion, right? So this formula delta L over Li over delta T, right? Delta T is the change in temperature, delta L is the change in length, and Li is the initial length, right? So if I can write delta L equals to alpha Li delta T, just multiplying this LHS into RHS, right? So we get this. Or so if I am saying delta L, that means I can write L final minus L initial equals to alpha Li, and if I am saying delta T, that means Tf minus T initial, right? So we can get this formula as well. Okay. So here I have written alpha equals to constant for small changes in temperature. Ti and Tf are the initial and the final temperatures. Li and Lf are initial and final lengths, right? Next is average coefficient of volume expansion. So the first one was linear expansion, right? So if I say linear, that means alpha. If I say volume, that means beta, right? So it's the same formula. If I'm talking about alpha, that means I am talking about length. Length. If I'm talking about alpha, that means I am talking about length. But if I'm talking about beta, that means I am talking about volume. So it's the same formula, delta L over Li upon delta T. So if I speak about beta, that means be delta V over Vi over delta T. Okay, it's the same formula. So delta V equals to this, if we multiply it, and delta V is Vf minus Vi, beta Vi, and delta T is Tf minus Ti, right? Now, what is the relationship between beta and alpha? So this formula also you need to remember, beta equals to 3 alpha. So beta equals to 3 alpha. Now there is another important equation, ideal gas equation, right? So there are some of the formulas you need to remember. N equals to m over capital M. So N is the number of moles, small m is the mass through the expansion, and capital M is the molar mass of the substance. Okay, so 1 mole of any substance is that amount of the substance that contains Avogadro's number Na equals to this. So there is an Avogadro number Na equals to this. All these values will be given to you in physics formula sheet. You just need to know how to place the formulas, and you will be given everything. So you need to remember this formula, N equals to m over m. And there is the ideal gas equation, PV equals to nRT, right? So P is the pressure and the unit is pascals. Small n is the number of moles, and we know the formula of small n, small m over capital M. And volume, V equals to volume meter cube, PV equals to Newton meter, and R, this value you need to remember, R is a constant, universal gas constant, and 8.314. This you need to remember it, but it will be given to you in the formula sheet as well. Okay. Now, as we know, N equals to N upon Na, right? This small n will be equal to capital N over Na, right? This thing. Now, that is number of moles equals to ratio of total number of molecules and Avogadro's number, right? This you need to remember. And we know that PV equals to nRT. So can I write PV equals to capital N over Na into RT, right? Just placing this N, this value N over Na, right? So I have placed this value here, so I will get this. Or can I write it PV equals to N Kb into T. Now what is Kb? Kb equals to R over Na, which is Boltzmann's constant. Okay. So this Kb, I've replaced it with R over Na. This R and this Na. Okay. So this is Boltzmann constant. So these are some of the formulas you need to remember for solving the numericals. The most important formula is PV equals to nRT. This is basically the ideal gas equation, and beta equals to 3 alpha. This formula, this one you need to remember for solving the numericals and for alpha, right? And the Celsius and the Fahrenheit scales. So these are some of the formulas you need to remember for solving the numericals.